Good morning everybody and welcome to our TV show today. The purpose of this short TV show is to do a short presentation on memory. I've brought along with me 4 of my colleagues today who will identify themselves by name, and we call ourselves the Mad Hatters as a group. So first I'm going to introduce, I'm Cathy Griffiths.
I'm Rhiann Jones.
I'm Sue Hunt.
I'm Georgina Banks. I'm Vindia.
How many of you ever say or ever have heard anybody say, I've got a memory like a sieve, or my memory is really bad? Has all of you come across that at one point in your life? Well, did you know that we have actually 2 parts to our memory? My colleagues are going to describe the memory in more detail, and I'm going to start with giving you a brief overview. Rhiann's going to give a more in-depth description of the multi-story model, and she's going to discuss the advantage and disadvantages. Then Sue is going to go into more depth about the working model of memory, and then she's going to introduce Georgina, who's going to explain the components of the central executive and the theory to back it up. And then Vindia is going to close by giving a summary and evaluation of the presentation that we're giving this morning. So I'm going to now pass it on to Rhiann, and she's going to give her input into the presentation. Thank you.
Well, a number of theorists have proposed that the memory system is divided into separate stores. And in 1969, Atkinson and Shiffrin developed the concept of the multi-store model of memory to describe how memory is organised. According to this model, memory is categorised as a flow of information through a system. And generally this happens in 3 stages. It happens with the sensory memory first, where information enters for a brief period of time, and a small amount of this information is then transferred to short-term memory, where it's held and manipulated. This is then transferred to long-term memory for more permanent storage. Sensory memory is able to deal with a variety of different types of information from the senses, like your smells, tastes, touch. The duration of storage in sensory memory may depend on the type of information processed. A visual image may remain unprocessed for about 0.5 seconds, whereas sounds may be stored up to 4 seconds. Evidence for this comes from Conrad in 1964. Short-term memory, however, allows us to retain information long enough for us to see it. It deals with new information that is transferred from the sensory memory, as well as old information that is transferred from the long-term memory. It plays an important part in cognitive thought and can be used as a kind of cognitive workspace. In contrast to sensory memory, short-term memory has a longer duration to about 15 to 30 seconds. This can be extended through rehearsal. Coding in short-term memory tends to be primarily acoustic, and that means that words are usually converted into sounds. And the last stage is long-term memory. This is a more permanent store that allows us to use past experiences and knowledge of the world to deal with future situations. There are evidence in support of the model, even though generally there's more criticisms to it, but evidence from studies of brain damaged patients, such as a particular one called HM, after having parts of his brain removed during surgery, he was unable to retain any new information and couldn't transfer any information from short-term memory to long-term memory, which shows the distinction between 2 separate stores. However, the multi-store model has been criticised for being too rigid and simplistic. Long-term and short-term memory are far too complex to be seen as unitary stores, and Bradley and Hitch in 1974 proposed a more comprehensive version of this model called the working memory, which Sue is now going to explain in more detail.
The working memory basically goes from the input to the sensory memory. The attention that is given to the sensory memory then moves it to the working memory or the short-term memory, and then that progresses on to the long-term memory. Short-term memory is known as many different things: primary or active or working memory. It's the information that we're currently aware of thinking about, or in Freudian psychology, this memory would be referred to as the conscious mind. The information found in the short-term memory comes from paying attention to your sensory memories. Dependent on how much attention you give to it will depend on how long it stays in there for. It's usually approximately 20 to 30 seconds, but it can be just a couple of seconds if rehearsal or active maintenance of the information is prevented. While many of our short-term memories are quickly forgotten, attending to this information allows it to continue on to the next stage, which is long-term memory. The amount of information that can be stored in short-term memory can vary, and an often cited figure is plus or minus 7 items, based on the results of a famous experiment on short-term memory. In an influential paper titled Magical Number 7 Plus or Minus 2, psychologist George Miller suggested that people can store between 5 and 9 items in short-term memory. More recent research suggests that people are capable of sorting approximately 4 chunks or pieces of information in short-term memory. This may be as chunks of numbers when you remember a phone number or something like that. Short-term memory is often used interchangeably with working memory, but the two should be utilised separately. Working memory refers to the processes that are used to temporarily store, organise and manipulate the information, hence its working. Short-term memory, on the other hand, refers only to the temporary storage of the information, so it's only there for a short term. The central executive, the most important yet least well understood component of Baddeley's 1986 working memory model, is supposed to be responsible for the selection, initiation and termination of processing routines, e.g. encoding, storing, retrieving. Baddeley equates the central executive with the supervisory attentional system, described by the Norman and Challis 1980 study and Challis's 1982 study. It drives the whole system. For example, it's the boss of the working memory, and it allocates data to the subsystems. It also deals with cognitive tasks such as mental arithmetic and problem solving. According to Challis in 1982, the supervisory additional system is limited capacity and is used for a variety of purposes, including planning or decision-making tasks, troubleshooting, in which the automatic process appears to be running into difficulty, novel situations, dangerous or technical difficult situations, and situations where strong habitual responses or temptations are involved. Extensive damage to the frontal lobes may result in impairments in the central executive functioning, and Baddeley's in 1986 coined the term, I can't even pronounce this, dissecutive syndrome, to describe dysfunctions of the central executive. The classical frontal syndrome is characterised by Rylander in 1939 as disturbed attention, increased distractibility, a difficulty in grasping the whole of a complicated state of affairs, and being able to work along old routines, but cannot learn to master new tasks in new situations, whereas the patient is at a loss. In other words, patients suffering from frontal lobe syndrome lack flexibility and the ability to control their processing resources. I'll pass you on to Georgina.
Yeah, the components of the central executive, it has 2 components consisting of the visual and spatial attention. And the attention component is aided by the peripheral independent system. There's a phonological loop and the visual spatial sketchpad. So basically we can remember things by seeing them as pictures in our mind, and it temporarily stores verbal and visual spatial information because it uses up the resources. And the theory of how they work, it shows that we have at least 2 parts of the short-term memory, and so that they can work together. And the visual part is a passive system, and it stores visual information and spatial locations in the form of static visual representation, so that we can actually see them as pictures how we remember it. And the spatial part is an active spatial rehearsal system that maintains sequential locations and movements, and also serves to refresh decaying information, and it's sometimes referred to as the inner scribe. And I'll pass on to my colleague who's going to evaluate and sum up everything we've talked about.
The memory is very important to human being and all other living creature. Virtually all of our everyday behaviors and actions for instant chatting, considerate interpretation, and socializing all depends on the information concerning on our surrounding. Memory permits us to recover actions from far away past or from a second ago. It allows us to discover new proficiency and it from behaviors without the aptitude to remember history, instance or information. Human will not be in a position to understand language, identify our associates and relatives, and know where we reside. Life would be a sequence of designed incident or each incident new and unknown. The verbal portion of working memory has a limited capacity. George Miller coined the chunk. To describe organized entry or thing in memory, working memory can be handled about 7 chunks at one time. To increase the amount of information in attention, one must increase the amount of information in each chunk. This can be done by organizing material into integrate wholes, each of which function has one chunk. However, chunking depends on matching incoming information and its representation in long-term memory, as Miller and Selfridge discovered in 1956.
So therefore, if we didn't have memory, we wouldn't have knowledge, we wouldn't have understanding, and we wouldn't have speech. So memory is a very important part of how our brain works. So thank you for watching our show today, and if you'd like to tune in tomorrow to watch a follow-up show, then you're more than welcome. Thank you.
Thank you.